So again, we're going to be looking at solving systems of equations. Last class we looked at solving systems of equations by graphing, and when we did that, the solution to two equations was the point at which they intersected. So what we're trying to find is we're trying to find where these two linear equations intersect each other. But sometimes it's not going to be given to you in a nice way to graph, so there's another method that we can do. And this method that we are going to use is called solving systems by substitution. When solving by substitution, there are three steps that we're going to follow. This might be a little confusing at first, but when we see a couple examples, it'll make a little bit more sense to you. The first step is that you want to find the variable that's already been solved for, or in some cases you might have to solve for a variable. The second step you're going to take is you're going to substitute the expression from step 1 to solve for a variable, and then the third step you're going to do is you're going to take the value from step 2 and plug that value back into the expression from step 1 so that you'll get an x value and you'll get a y value. So again, let's take a look at a couple examples so that that makes sense to you. Alright, in this case, the two linear equations that we're given are y equals 3x plus 2 and x plus 2y equals 11. So back in step 1, it says find the variable that's solved for. Alright, well in this case, we have a variable that's been solved for. Y has been solved for. We see that y equals 3x plus 2. My second step says that I need to take that expression and plug it into my other expression. Alright, so here, since y equals 3x plus 2, and then my second linear equation says x plus 2y equals 11, well, I have a y right here. So what I'm going to do is I'm going to take what y equals in the first equation and plug it into my y in my second equation. So that means what I'm going to have is x plus 2, but then instead of putting y in there, I'm going to put 3x plus 2 equals 11. So all I did is from here to here, I substituted a new expression for y. Well, now I have one single variable, x, that I'm going to solve for. So the first thing I have to do on the left side is I have to distribute right here. So I have x plus 2 times 3x is 6x, plus 2 times 2 is 4, equals 11. So on the left side I have to combine like terms, so I get 7x plus 4 equals 11. Solve for x, so I'm going to subtract 4 on both sides. 7x equals 7, divide both sides by 7, so x equals 1. Alright, well that's going to be the first part of my answer. The second part of my answer comes from taking this value of 1 and plugging it back up here into our first equation so that I can figure out what y equals, because again, when I solve I have to have an x value and I have to have a y value. So I'm going to say y equals 3x plus 2, but I know that my x value is equal to 1. So I'm going to say y equals 3 times 1 plus 2. So that means y equals 3 times 1, which is 3, plus 2, and 3 plus 2 is 5. So the solution to that system of linear equations by substitution is the ordered pair 1, 5. Let's take a look at our second example. Our second example, we have the two linear equations x minus 2y equals negative 6 and 4x plus 6y equals 4. Alright, so again, my first step is I need to find a variable that has been solved for. Well, if we take a look at both of these linear equations, neither one has one variable all by itself. My first one I have x and 2y on the same side, and I also, on my second equation, have 4x and 6y on the same side. The easiest one that I can find to figure out what one variable is by itself is if I look at this first one. Right, because in this first one, x has a coefficient of 1, so that's going to be the easiest to get by itself. So if I look there, I have x minus 2y equals negative 6. Well, in order to get x by itself, I have to get rid of 2y, so I'm going to add 2y to both sides. And when I do that, I get x equals negative 6 plus 2y. Alright, well let's go ahead and bring down what our second equation is, which is 4x plus 6y equals 4. So now this is the system that I'm working with. now I do have x by itself. So again, now that I have x by itself, since x equals negative 6 plus 2y, I can take that expression, and in my second equation, I can substitute it. So now I'm going to have 4 times, and then instead of saying x, I'm going to say what x equals, which is negative 6 plus 2y, and then bring over the rest of my equation, which is plus 6y equals 4. So on the left side, first thing I have to do is distribute, so I'm going to distribute that 4. So I get negative 24 plus 8y plus 6y equals 4. On the left side, I still have to combine like terms, so I get negative 24 plus 14y equals 4. Now I have to get y by itself, so first I'm going to add 24, and I get 14y equals 28. So then I have to divide both sides by 14, and I get y equals 2. So I know the first part of my answer, the second part of my answer is 2, because it's my y value that is 2. And remember, an ordered pair goes x comma y. Alright, now that I have what y equals, I have to figure out what x equals. So again, I'm going to look at my equation that has x by itself, and I know what y equals now, so I can take my y value and I can plug it in. So that means if I'm working with x equals negative 6 plus 2y, I know that my y value is 2, so I can just take it and plug it in. So I get x equals negative 6 plus 2 times 2. And then I can evaluate that. So that means x equals negative 6 plus 4, so x equals negative 2. So my solution would be the ordered pair negative 2, comma 2.